Okay, in this question, we are going to try show in part A that P is collinear with A and B. So we are expecting a scenario that is something like this, where point A, point B, and point P are supposed to be lying on the same straight line. So in order for us to prove this, we are given an equation, which is P is equal to lambda A plus 1 minus lambda times B. So making use of this equation, I'm going to try to see whether I will be able to code a vector joining two of the points here to be parallel to another vector joining another two of the points that are here. Then we will be able to show the collinearity of these 3 points. So to do that, let's try to find a way to re-express this. I don't think there are a lot of different ways that we can do this. So I'm going to expand this first. So this will be B minus lambda B. I'm going to shift B over to the left-hand side to combine with this P. So P minus B that is going to be on one side. My intention is to bring all those with lambda to be on one side, which is going to be A minus B. And for this is actually just going to be equal to BP, the vector BP. So it is this vector, and this is equal to lambda of this. This is BA. So that will be this vector. So we now have two vectors where they share a common point, which is B. And since these two vectors, they are parallel to each other, that means A, B, P, they are collinear. So therefore, we can say that P is collinear with the other 2 points, A and B. Okay, this is for part A. And in part B, we are now given that angle AOB is 90 degrees. We want to show that the position vector of the foot of the perpendicular from the origin O to AB is going to be expressed as that. So let me draw a diagram to represent this part B. Let's say I have a line, and this line passes through point A. This line passes through point B. So we are going to reference this to the origin such that AOB is 90 degrees. So let me draw something that is, let's say, like this. So here, for example, is the origin. So this is 90 degrees, and we are supposed to try to show that this vector here, the foot of the perpendicular from the origin to this, I am going to call this point here F. Okay, so we are trying to show that OF is equal to that. So to do that, I'm going to first form for myself a line that passes through AB, which is R is equal to, let me use the position vector of A, which is going to be this. So A plus lambda of AB. AB is going to be vector B minus vector A. So this minus this. Okay, so this is going to be a line that will be passing through AB. So this equation here, or rather R that is here, will represent any point that is going to be on this line. And since F is a point that is on this line, we can say that OF is going to be this A plus lambda of B minus A. And the special thing about OF is that OF is perpendicular to this line that passes through AB. So it is going to be perpendicular to this. So we will take OF dot this vector B minus A, which is parallel to the line that passes through AB. This should be equal to 0. Our intention is to try to solve for lambda. So from here, it is going to be A plus lambda of B minus A. So we have this dot B minus A. This is equal to 0. So it is going to be A dot B minus A plus lambda of B minus A dot B minus A. This is equal to 0. So this will be A dot B, which is going to be 0, and minus away A dot A plus lambda of this, it will be B dot B, this minus B dot A, this minus A dot B, this plus A dot A. This is equal to 0. So because angle AOB is 90 degrees, so A dot B is going to be equal to 0. I'll be left with this. A dot A is modulus of A square plus lambda of B dot B is modulus of B square. This will be 0, this will be 0 again. It is because the angle AOB is 90 degrees. This is going to be plus modulus of A square. This is equal to 0, which means that lambda is going to be this, bring over to the other side. We have a modulus of A square divided by this, which is going to be modulus of A square plus modulus of B square. And if we were to try to show what we are trying to be showing according to what the question wants, it is going to be us having this point, the position vector of this point F, the foot of the perpendicular, with lambda now being substituted by this. So therefore, the position vector of the foot of the perpendicular is going to be equal to A plus lambda, which is going to be modulus of A square divided by modulus of A square plus modulus of B square of B minus A. And this is what the question wants us to show.